In this video, we're going to be looking at how Akka Cluster works. This is a Akka Cluster Quickstart Dashboard series, and we're in part 2, where we're going to be focusing on cluster node lifecycles. Hi, my name is Hugh McKee. I'm a developer advocate for the Akka platform at Lightbend. So the focus of this video is really just looking at the life cycles of nodes in an Akka cluster. So I'm going to be explaining, what is an Akka cluster, what are nodes in an Akka cluster, and also some of the states that nodes go through. And to do that, we're going to do things like look at how nodes form themselves into a cluster. And we'll also look at what happens when nodes leave or join a cluster. And then some of the more interesting things are things like what happens when nodes are unreachable. What is an unreachable node, and how do Akka clusters handle that, and what are some of the things that you can do to recover from that. The demo that I'm going to be doing is based on a project that is available to you. Everything I'll be showing you is available for you to use yourself, including the dashboard that I'll show you in just a minute. But the requirements are fairly simple. You just need Git, you need Java 8+, you need Maven, and then here's the URL to the project. It's in GitHub under my username McKeeH3, and the project name is Akka-type-java-cluster. To get started, I'm going to first go through the steps of installing the project, the demo project, and getting things back up and running. So right now, I've already got the project installed, and this is an example view of the dashboard. I've done a few things where I've done some things with different nodes in this example cluster, but I'm going to just kind of start fresh. So I'm going to shut this cluster down and then remove the project, and we'll go from the beginning. So there's some scripts that are provided. I'll go into a little bit of detail on how that works in a moment, but first I want to just go through and shut down this cluster. And the dashboard is live, so it's showing a cluster running. So right now you can see that there's 9 nodes in there, 9 nodes that'll show. One of the nodes shows unreachable. The other 8 were running, and now everything's shut down. So I'm going to close this tab. I also want to show you that this is what we're going to be focusing on. This is in the Akka documentation, in the cluster membership services section of under cluster, but it's a nice diagram that we'll be kind of walking through, but visually through the dashboard, about the different states that nodes within a cluster go through, and these states are visualized in the cluster itself. So I'm going to go to a command window here, and back in the command window, and I'm going to go up a directory and remove this this project. Sorry. Screwing this all up. Remove the directory, and then I'm going to do the git command. So here's the git command as I was showing you earlier in the slides. I'm going to clone this project and then cd into that directory and do a Maven clean package. So it's all set up to just do a quick build of the project, pull in all the dependencies and everything. It only takes a moment, and we should have the built project. And once that's done, wanted to show you a little bit about what's in the project itself. There's a number of script files that are provided in this project. These scripts are specific for this demo, not for, say, a general purpose Akka cluster. I set these scripts up just for this demo. It's really all rooted off of an Akka kind of main script. And as you can see, there's some help in this script. The commands that are available in this script are focused on, there's a set of commands for starting, stopping, and doing things at the cluster level. There's another set of commands that are focused on doing things at the node level, like starting and stopping individual nodes or a few nodes, not like starting up the whole cluster. These are more convenience commands. They're basically doing the same thing, but it's just a difference in syntax. And then there's a third set of commands that I'm not going to be going into in this video that are more at the network level to simulate some things that can happen in a network that's running in a cluster. But right now what I want to do is I want to start up the cluster. So there's a command to do that. It's just Akka, /Akka cluster start. It defaults to starting up a cluster of 9 nodes. The maximum number of nodes that this demo runs is 9. Because of the way the dashboard is laid out. So what's happening here is on my laptop, I'm running 9 individual Java processes, JVMs. Each Java process is set up to start up on the network. They're using different ports for collaborating, because all these nodes are forming themselves into an Akka cluster. In order for them all to communicate, they need to be able to communicate locally. So everything's up, opening up on localhost. But I'm using different ports like 2551 for node 1 through 2559 for node 9. And then once that's up, the cluster's up, there's a dashboard command, Akka Cluster Dashboard. So if I enter that command, and if everything went well, here we go. We have a cluster up and running. So I want to first kind of show you a little bit about what's happening in the dashboard itself here. What's this dashboard showing? So on the right, there's this little matrix of 9 views of the cluster. And you can see, if I zoom in, say, on say 2551, that this is a perspective of what the cluster looks like from node 1 in the cluster. There's 9 nodes running. I could run 1, I could run 4, I could run however many I want, up to 9 in this demo. Of course, with real Akka clusters, you can run many more nodes. But for the sake of this demo, I wanted to limit it to 9 because I wanted to be able to show everything I needed on this dashboard. So here's a view of 2551. So what it's showing is here, it's showing what the cluster looks like. All the other nodes, including itself, all 9 nodes, it's showing the 2551's view of what the cluster looks like from its perspective. And what I mean by that is that 2551 is aware that there are other nodes in the cluster. When each one of these nodes started up, remember, it's just a single JVM that's starting up, and then we're starting up Akka when those JVMs run, that 2551 came alive. It brought up Akka. Akka started doing its thing, and a big part of the Akka cluster feature, which as a developer, I don't really have to do much, but as far as what Akka is doing is pretty significant. It came alive, and it started, it connected itself up to the network, and it started looking around for, are there other nodes out there that we should form ourselves into a cluster? And all this happened, and as a result, what we're seeing is that from the perspective of 2551, that it sees that, yep, I'm running, and so are the other 8 nodes in this cluster. And I'm using the green to show that all the nodes show that they're up and they're healthy. So I'm showing the port number here, so 2551, 2552, 2553, and so on. Then I'm showing the state of the node. Each node has a different state depending on how its health, basically. And each node right now is showing that it's up. So this goes on throughout the the entire view of the dashboard. Another thing I want to point out is that 2 of these nodes, node 2551 and 2552, also show that they're seed nodes. And seed nodes is one strategy for how clusters form themselves. So what I mean by that is that as each one of these nodes started up, they start up and they look at their configuration. So each one of these nodes has a slightly different configuration, particularly the details of what node am I, what port am I on, that type of thing. So they all start up and they start looking at themselves and go, so 2551 came up and looked at itself and goes, oh, I'm configured as a seed node. What that means is I'm one of the nodes that other nodes will try and contact when they're going to join the cluster. So in contrast, if we look at, say, 2554, which is the next node below it, 2554 is not a seed node like 2551 and 2552. So when 2554 started up, it goes, oh, I'm not a seed node. What are the seed nodes? And it can retrieve that information from its configuration. And it goes, oh, 2551 and 2552 are seed nodes. So what's happening then is 2554 reaches out over the network and says, hey, 2551 or 2552, whichever one it grabs, I would like to join the cluster. So they start talking to each other, and they reach an agreement that, yep, all right, 2551 says, yeah, you look good, okay, you can join the cluster. So there's this whole process of joining the cluster. And that kind of gets back to the diagram here. That as a node starts up, it says, it asks to join the cluster, and it goes through this process. And while it's joining the cluster, it's in a joining state. And it will either get promoted to an up state directly from joining to up, or it could go through another process of being weakly up and then going up. Now, what path each node actually takes from wanting to join the cluster, being in a joining state, and then ultimately being promoted to up is decided by what's called a leader action. And I'll describe what a leader is in just a minute. So in any case, this is what happened when I ran all 9 nodes at once. These 9 JVMs started up. Each one independently has to bootstrap themselves. They have to figure out, who am I? What's my port? How do I communicate with, the other things that are in the cluster? the 2 seed nodes, they boot up and they realize that they can look at the configuration and see that there's 2 seed nodes, so they connect up with each other. And then all the other nodes, when they start up, they reach out to one of the seed nodes and say, hey, I want to join the cluster. Now, this is just one of what's called the Akka Cluster bootstrap processes. As an example, if we're running in a Kubernetes environment, this process is completely different, because here with seed nodes, I'm really basically using static IP addresses and static port numbers, which really isn't going to work in a Kubernetes environment where all the network addresses are very, very dynamic. So there's an entirely different process for bootstrapping a cluster in Kubernetes. But it's still mechanically somewhat the same, that individual JVMs come up and they know they need to have something fed to them or some information that they can use to find other nodes in the cluster, and they start collaborating with each other. So that's what's got us to this state. We've got a cluster of 9 nodes up. So this is what's being shown on the right. Again, each node is showing what its perspective of the cluster is. So like 2556 here is, has the same view of what the cluster looks like as 2554. Now the way the dashboard works is that it's, this is JavaScript. It's running here in my browser. The JavaScript is periodically, at a fairly high rate, pinging each one of these individual nodes, and it's asking each node, give me what you think the cluster looks like. And those individual nodes are feeding this back to the dashboard, and the dashboard's rendering what this looks like. So as I play around with the cluster, and you'll see this if you play around with it on your own, that changes to the cluster propagate at their own rate on individual nodes, because there is no master here. Nobody's really in charge. There is a leader, and I'll explain what that is in a moment. But this is a masterless type of system. It's a collaborative type of system. So one thing I want to kind of go back through again is let's go into the project and let's start playing around with some of the commands. And I'm going to stop one of the nodes. I'm going to stop node 5, say, since it's right in the middle of the 9 here. And what you can see is, it's leaving. It happened quickly. Now it's saying it's exiting, and then it's shut down. Now, if you watched the view of the state of node 5 wasn't in lockstep on all of the nodes in the cluster. it happened fairly quickly, but you could kind of see in the dashboard that node 5 going through its different states to ultimately being grayed out because it's not running anymore happened at different times within these different nodes in the cluster. And again, that's because each one of these nodes is running independently. They're each trying to maintain their own view of the cluster. So we watched a node shut down. And if we go back to the diagram, what we had node 5 was up, and I executed a command that basically told the JVM to shut down, which triggers an action in Akka to do a graceful shutdown, which ultimately means that the Akka actor system is going to say, hey, I want to leave the cluster. So once that's announced, the node goes into a leaving state. And then when it's in a leaving state, it then transitions into an exiting state. And then ultimately it goes for removed. So we did see that in the cluster. It happened quickly, but for a moment we saw it showing in a leaving state. And then we saw it showing in an exiting state. And then now it's gone. It's all grayed out. So that's the process that we just went through. So if I'm going to start up the node again, node 5, just to go through the startup process, but just for a single node. So let's start 5. And it's just Akka node start 5. You can start more than one node if you want. The scripts are a little bit flexible. You can give known numbers. I'm not asking for the script isn't requiring that you give the port. It's just by node number. So it's a matter of convenience. So let's start node 5. So the JVM's starting up, and then you can see it's joining, and then it goes up. But again, the whole process kind of propagated through the cluster. Each node individually at their own pace recognized that node 5 was joining, and then it was promoted to an up state. So if we go back to the diagram again, this is the join. The node 5 started up. It ultimately started up Akka, and then Akka was set up to do, say, hey, I want to join, the cluster, which means it had to figure out where the seed nodes are, and reach out to one of those seed nodes and send a message over the network and say, I want to join. And then the node went into a joining state, and then it was promoted to an up state. Now notice in the diagram, this is where it says this arc between joining and up, or weakly up and up, is what's called a leader action. So what's a leader? What does this whole thing mean? So in this dashboard, I'm showing where the leader currently is located, which node currently has the role of leader. Now any node in the cluster, depending on the circumstances, can become a leader. So right now it happens to be the 2551, node 1 is the leader node. So what this means is that when node 5 on port 2555 said, I want to join the cluster, and it reached out to one of the seed nodes, the decision to up the node was really made by 2551. The reason for this is that it avoids confusion, like who makes the decision in the cluster that a node should go to an upstate? Because promoting a node to an upstate is important. Because it means that it's fully ready to participate in the cluster. So to avoid the confusion about who should make this decision, there's a really simple strategy for identifying the leader. Any node in the cluster can know who the leader is just by knowing what the IP addresses are of all the nodes in the cluster. The strategy that's being used right here is that the node with the lowest IP and port is the leader node. So right now, the lowest IP and port, they all share the same IP on the local host IP, but it's port 2551. So the leader's on 2551. So that's what's happened, and this is what that diagram is showing, is it was 2551 in the sample that promoted the node 5 from a joining state to a up state. So that's kind of starting and stopping a node. But let's have a little bit more fun. Let's do something a little bit more, I guess, tragic to the cluster, and let's kill a node. So I'm going to kill node 7. And there's a big difference between a kill and a stop. So I basically just did a kill -9 on the process for node 7. And what you can see here, though, is that node 7 is showing, from the perspective of the remaining nodes in the cluster, that it's unreachable. And what this means is that while the cluster is running, all the nodes are gossiping with each other, is what they call it. And basically what they're doing is just keeping an eye on each other. Checking, like node 1 is checking on some of the other nodes in the cluster to see if they're still there. Are they responding? Things like that. So all the nodes collectively are checking on each other to kind of keep what's happening in the cluster. So we're running along, and all of a sudden, node 7 simply stopped responding. And all these other nodes are set up to, they're very often gossiping with each other, and they pretty quickly recognize that node 7 stopped responding. They're just not getting any responses back from their gossip pings from these other nodes. So the cluster goes into this situation where it's like, node 7, it didn't say it was leaving. It didn't go through any kind of an orderly shutdown. It's just gone. We don't know what's going on. The process could still be running, but the network between us and node 7 is broken, or it could be the process is down. Who knows what's wrong? All we know is we can't communicate with it. So this is not a good situation because the cluster's in kind of a state where it really can't make any node level decisions, because when a node is unreachable, it's said that the cluster can't reach convergence on being in a kind of a stable state. And when that happens, the current leader becomes in a state where it can't make certain critical decisions. And those decisions are things like upping a node or having other nodes leave the cluster. So we go back to the diagram. This leader action for joining from to an up state requires that the cluster be in a convergence, be in a healthy state. Likewise, for nodes leaving the cluster, the leader has to be happy, basically. And right now, because at least one of the nodes in the cluster isn't responding, we don't know what's wrong with it. It could come back at any moment and resume normal processing. We just don't know. But right at the moment, we're just not getting any response back from node 7. So another thing I could try then is let's try and stop another node. So I'm going to try and stop, say, let's say I'll try and stop 5 again. All right, so we're going to try and stop node 5. Now this is an orderly shutdown versus just a flat out kill of the process. So node 5 goes through, it's going through leaving, and then so it wants to leave, but it's kind of, in a way, it's kind of stuck there. Now it might switch to unreachable in a moment, but right now there it goes. It goes to an unreachable. And this is where, if you look at the diagram, we had a node that was up. It went through the process. It was trying to be good, say I want to leave the cluster, so it's announcing I want to leave. So it went into a leaving state. But the leader isn't able to allow that node to fully exit because we have something unreachable in the cluster at the moment. So we're kind of stuck. So this isn't good. We can't restart node 5. We don't know what's going on with node 7. Things like that. So one of the manual recourses that you can go through is to down nodes. So there's, as you might expect, there's a Akka node down script. And there's a little bit more in the parameters here, although this is a default. But there's an optional parameter called via. what this means is that I'm going to send a down request to node 1, asking it to declare a node, in this case, node 7, is down. So I had to talk to an up node, a node that's running, to be able to ask, tell at least one node in the cluster, hey, we need to down node 7. So I'm going to execute this command, and let's see what happens. And so hopefully what we'll see here is node 7 goes away. But then also notice that now that the leader is happy again, because we don't have any unreachable nodes, the leader could finally complete the action to start up. I'm sorry, to exit, fully exit node 5. So now 5 and 7 are gone. All right. So that's an example of having a node that's unreachable because it's not accessible, as well as having a node that's stuck in a certain state, like in this case, stuck in basically, it wasn't able to go from leaving to exiting because the leader was unable to perform what it normally does when everything is good as far as the remaining nodes in the cluster. So another situation I want to show you is what's called weekly up. So in order to do this, first I want to, let me restart nodes 5 and 7. So there's 5 and I'll add 7. So we should see, let's see, both those nodes should come in here. So it's joining and then kind of propagates through the cluster, as you might have seen, and then we're all back up. So first I'm going to stop nodes 1 and 6. Let's stop nodes 1 and 6. So stop 1, stop 6. And we can see, leaving, exiting, and then we should see them gone. All right, so those guys are down. And then I'm going to kill, say let's kill node 8. We'll kill node 8. And now the cluster goes into, where the leader is not happy because we don't have convergence on the state of the cluster. And so things aren't good. But I want to show what happens when I try and restart nodes 1 and 6. So I'll start nodes 1 and 6. And they should start coming up. There's joining, but now they say weekly up. And they're stuck there. And the reason why they're stuck there is that it is okay for a node to go from a joining to a weekly up state when the leader is unable to promote fully to an up state. But so the node is up and running, but things aren't quite right with the cluster because we have at least one node that's currently unreachable. So these two nodes are stuck in a weekly up state. And that, going back to the diagram, you can see joining, going to weekly up, does not require the leader, right? So that arc here between joining and weekly up, it doesn't say it's a leader action, but the leader action from weekly up to up does require the leader. So how do we fix this? Well, one way to fix this is that we need to down node 8. So if we execute that down command for node 8, now I can't do it via 1 because 1's not really in a good shape. So I'm going to down via node 2, and I'm going to ask it to down node 8. So Akka node down via node 2, send a down request to node 2, and ask it to down node 8. Now, the reason I'm saying it to 2 is because that's where the leader's at, and the leader's happy. So let me try that. And hopefully what we'll see is that node 7 goes to a fully down state. It's not running. And then you can see the nodes 1 and 6 finally went from a weekly up state to a fully up state. So that gives you kind of an idea of some of the transitions that are happening as you do things in the cluster. And of course, the dashboard here is it's this live view of what's happening in the cluster. So hopefully this will give you some insight as to some of the dynamics of how things work in Akka. Again, this whole project is available. This dashboard is available. You can grab it and play with it. It's a really simple project. And in future videos in this series, I'm going to go into a little bit of a code review of how this project is laid out. And in another video, I'm going to go into a code review of how the dashboard works in more detail. But the main intent of having this, this dashboard available in this project is to allow us to kind of, see things happening in the cluster, live while things are happening. And with the scripts that I provided in the project, you can do whatever you want. You can play with all kinds of different combinations of starting and stopping. And I've played around with this a lot. And to be honest, I've learned a lot as well. So it's quite a bit of fun, I think, to have a visualization of things happening in the cluster instead of, say, pouring through log files or things like that. One thing I want to mention as I'm wrapping up here with this video is that the reason why it's so important to have these actions that I was going through, particularly the ones where they're the leader actions and where we're changing things from nodes basically being getting promoted to an up or exiting the cluster, is that it's because of the actors running in the systems themselves. Actors by their very nature are stateful. And that means that you can have certain actors that are running somewhere in the cluster that are maintaining or handling the state of a particular thing. So, say, for example, the classic example of, say, an order. So there's one actor that's handling the state of your order, and there's another actor that's handling the state of my order, and there's tens of thousands or hundreds of thousands or millions of other actors that are handling the state of other actors, or of other orders. And when we have changes in the nodes that are running in the cluster, that changes the distribution patterns for how these stateful actors are pretty much distributed across the cluster. When we get a situation where the cluster can't reach convergence, that means that we really can't move any of these actors. So in a normal situation, when everything's happy, and say we have a node that leaves the cluster, any of the actors that formerly resided on that node that left the cluster could safely be started again somewhere else in the cluster to resume processing of the state. So say my actor for my order was on, say, node 8 here, and it went through an orderly shutdown, but I'm still interacting with my order. So another instance of an actor for my state, for my order, needs to be started somewhere else in the cluster. In order for Akka to be able to make those kinds of decisions about where to distribute stateful actors across the cluster has to be basically healthy. So that's a really kind of a quick explanation of the core reason why this whole state thing is handled so carefully by Akka itself. So hopefully that helps. The thing I wanted to point out is this is the end of part 2. What's next is I'll be doing a part 3, and this should be a relatively short video where I'm going to do a code review of this project. There's not a lot of code in this, other than the dashboard, but part 4 will be a code review of the dashboard. Here's a link again to the source code that I use for this project. You can grab it again, play with it. The dashboard's there for you to play with, tweak it. If you know JavaScript, go nuts. Have a ball with it. Maybe do something cool on your own. Of course, the Akka documentation is here at akka.io/docs. And if you're new or interested in learning more about Akka, reach out to us and schedule a demo. So thank you very much. Again, my name is Hugh McKee, developer advocate for the Akka platform. Here's my Twitter handle, my email address, and hopefully I'll see you in future videos.